Hello guys, my name is Isaac Flores and today I'll be explaining user-defined classes. As we know, Java is an object-oriented program, and for this video I created a planet class since my program will use planets as objects. I should note that when defining a class we set the visibility as public so that other classes can have access to this class. Also note that I imported a Java package, math, because we'll be using it for our method. Okay, so let's talk about fields. And we can see that they are in this area of our planet class. So in defining the planet class, we first write down the information that is relevant to this object, also known as the class fields. In this case, the objects are planets, and the relevant information or fields are the planet names, the mass, and the radius, as well as some other constants such as pi and g for a gravitational constant that we'll use in one of our methods in our calculations. Now, the fields are declared using instant variables, which are variables declared outside a method but within a class that are instance specific for that object. Note that we have set visibility for the fields as private, meaning that the information that is contained within the fields can only be accessed within the class and cannot be modified or accessed from another class except by defining getters and setter methods, which we'll talk about later on in this video. Now moving on to constructors for our planet class. When we create a new object, a constructor will initialize the fields in the class according to the arguments that the constructor takes. We can overload constructors by using the same constructor name but containing different parameters. For instance, the planet class has two constructors that the first one we see here takes no arguments, and our second constructor takes the name that we want to set for our planet, the mass, and the radius, and also contains an if or else statement in case that the information that we set for a new object does not make any sense. For instance, like a negative mass or a negative radius. Now, if we notice, constructors do not have a return type and are set to public. Another thing to notice is that when a class has no constructors defined in it, you're still able to create an object in that class. This is because compilers contains a no argument constructor that will set all fields to null or zero depending on the data type. Now, moving on to methods, as I had mentioned earlier, the fields in our class is set to private, and in order to access and modify information on the planet class from other classes, we need to define a public getter method. Those allow us to access private fields, and setter methods that allow us to modify information on the private fields from other classes. So this is our getter. This gets the name, this gets the mass, and this gets the radius. And then the setter again sets the mass, sets the name, sets the mass, and the radius. I've also defined two other methods, a toString method, actually three other methods, a toString method, a method to calculate the surface area, and a method to calculate the gravitational acceleration of the planet that we're talking about. Now, since we're talking about methods, this is probably a good time to talk about inheritance. There is implicit and explicit inheritance. So when you create a class, it will always have implicit inheritance to the object class, which means that all the methods and fields in the object class are accessible, in this case, to the student class. Now, we can extend, we can extend the class explicitly as well by adding next to our class declaration extend, and then declaring the class that we are extending to right in this line of code. The class that we extend to becomes superclass, and the class that we extend it from becomes the subclass. So, for instance, in implicit inheritance, the object class would be the superclass, and then our student class would be the subclass. Now let's look at our program in our main method and see what we're doing here. So this program just essentially allows us to use our objects in the planet class to calculate how much a person weighs at the surface of any planet, but in this case we'll be talking about Earth and Jupiter. So we start here by defining a set of constants, including Earth's mass, which uses an exponential function to express it, Earth radius in meters, also Jupiter mass, and Jupiter radius in meters again. Well, this is in kilograms, the mass is in kilograms. So the first thing is that this line of code 15 creates a new planet object with the variable name planet1. Now notice that there is no arguments here, so meaning that the constructor will use the no argument constructor, which sets all the instant variables to default. The planet name is let me see, constructors. Oh yeah, it sets it to not set, and mass to 0, and radius to 0. So that's case 1, and then in this line of code, I purposely set a negative mass, and that is to test the if statement for erroneous inputs and to produce an error message, and we'll see what we get with that. And then here finally we create planet another planet object, planet 3, and it has Earth's name. It has its name as Earth, Earth mass, and Earth radius, which takes from this constants that we set here. Now this will use the constructor that intakes the 3 parameters. We did the same here for Jupiter. So now we have planet 3 is Earth, planet 5 is Jupiter. Now to calculate Earth and Jupiter's gravitational acceleration constant at the surface, we use it using a method called PlanetAccel, and it'll do it in meters per second, which is planet acceleration. It's the method is planet acceleration, which will use this method. And the way we go about calculating that, the formula for that is here. This is how we calculate our acceleration. We have defined this big G as a gravitational constant in our field, and then our method calculates this formula for us for each planet. And so it calculates acceleration for Earth and acceleration for Jupiter at the surfaces. Now we also want to calculate the weight at the surface of Earth and Jupiter of an object with the mass of 100 kilograms using Newton's laws. Force equals mass times acceleration. Note that force is in newtons, so we need a conversion factor from newtons to pounds, this is our conversion factor. So this is F equals ma, and we'll calculate the person's weight in pounds on Earth, and then it'll do it for Jupiter. Finally, we'll calculate Earth's and Jupiter planet surface area, using the surface area method defined in our planet class. So when we compile and run, we see that for the first case, the constructor set everything to default for that object. Then we also, when we try to set the incorrect mass, we got an error message. Finally, we defined Earth, and it tells us its radius and its mass, and then Jupiter. Then we calculated the gravitational constant for Earth, which is right 9.8. And then the gravitational constant for Jupiter at its surface, which is very close. It should be 24.5 0.9. That's one off. And then so then we calculate the weight for the surface at Earth for 100 kilogram object, 220 pounds. And then for that same object, because Jupiter is much bigger, it would be 582 pounds. The surface area are correct as well when we calculate surface area of Earth, and this should say Jupiter. But we see here that Earth is right, and we see here that Jupiter calculated it right as well. All right, that's all for me. Thank you very much. Sorry this video extended so long, but there's a lot to talk about. If you guys have any questions, please feel free to provide me with feedback. Thank you guys.